Hello everyone. We have already seen in the previous video that a galvanometer can be converted into an ammeter to measure the value of current. Now here in this video we are going to discuss that how galvanometer can be converted into a voltmeter to measure the potential difference between 2 points in a circuit. So let us see how it is done. When we want to convert a galvanometer into a voltmeter, first we need to know what exactly it does. A voltmeter is a device for measuring potential difference across any 2 points in a circuit. That is, you choose any 2 points in a circuit, so it measures the potential difference between those 2 points. Let me give you an example here. Suppose I take a circuit here where a resistance is connected there and the wire continues. Okay, and let's say this be the direction of current. Let's say I current flows through the resistance R. R is the resistance of the circuit, so I is the current which flows through it. Okay. Now we want to measure the potential difference between these 2 points. Let this be one point and this be the other. So we always connect a voltmeter in parallel to the circuit element. This is the symbol for the voltmeter. We have connected a voltmeter here, and it is connected in parallel with the circuit. Now we will be measuring the potential difference between these 2 points. This is one point and this one is the other point. So to measure the potential difference between these 2 points, we have connected a voltmeter here. Now one very important thing you need to understand here, initially the current I was flowing through the resistance, but now the current has another path also, so a very little of the current has to pass through this voltmeter also. So if the resistance of the voltmeter is less, so you will find that a large amount of current flows through the voltmeter, and because of the connecting of this instrument to measure the potential difference, the current through the resistance decreases. That is, the potential across the resistance decreases. So this cannot happen. That is, by adding a voltmeter in the circuit, if we decrease the amount of current appreciably through the resistance or through the circuit element, then there is no meaning of using such an instrument, because the voltage here is decreased because the current passing through the resistance decreases. So to avoid that, we must have a voltmeter with a very high resistance. The resistance should be very high so that a negligible amount of current flows in this direction, and almost all of the current which was initially flowing through the resistance will now also, after connecting the voltmeter, almost the same will pass through the resistance. So this won't be there won't be any effect in the value of current which flows through the resistance. That means the voltmeter is a very high resistance device, and it is always connected in parallel to the circuit. Now by high resistance we mean that in ideal condition the resistance should be infinity. So I hope this is clear to you. A voltmeter is a device which is always connected in parallel, whereas we have seen that for an ammeter it is always connected in series with the circuit and its resistance was very low. But here voltmeter is connected in parallel and its resistance is very high. So I hope this is clear to you. So when we consider a voltmeter, it is connected parallel with the circuit element across which the potential difference is intended to be measured. As a result, a small part of the total current passes through the voltmeter because its resistance is very high, and so the current through the circuit element decreases, and so the current element through the decreases by a very small amount. Now, to avoid this, the voltmeter should be designed to have very high resistance. I hope this is very clear to you. The voltmeter should have very high resistance so the current through the circuit element remains constant or almost the same. That means when we consider an ideal voltmeter, then for an ideal voltmeter it must have an infinite resistance. Now we see here, this is the diagram of a voltmeter. We have a galvanometer which allows a maximum of Ig current to pass through it. So the galvanometer now measures the voltage, maximum voltage, Ig into G. So what we do is, we connect a resistance, very high resistance, much greater than the value of the resistance of the galvanometer. So we connect it in series with the galvanometer. Now the total resistance of the voltmeter, which is a combination of galvanometer and a resistance in series, the total resistance becomes G plus R. And the voltage now that it can measure is, there is a range of the voltage from 0 to Ig into G plus R. So that you need to understand very clearly. Here some of the terms which we have considered here. G is the resistance of the galvanometer, Ig is the maximum current which passes through the galvanometer. 0 to V is the required range of the voltmeter, and here the value of V will be Ig into G plus R, where R is the value of very high resistance. So this is the very high resistance which we are considering here. The whole system of series combination of galvanometer and the resistance is known as voltmeter. The total resistance of the voltmeter circuit is R plus G, since they are in series. Now the current here is potential difference upon the total resistance. If the potential difference, total potential difference is V upon the total resistance is R plus G, then the value of R plus G will be given by V by Ig. Or finally, the value of R, which is connected in series with the galvanometer, will be V by Ig minus G. You need to remember this equation. The deflection in the galvanometer, you need to understand, the deflection in the galvanometer is directly proportional to Ig. Now, this value of Ig, we know that V is equal to, we write here Ig into G plus G. So, if the deflection of the galvanometer is proportional to Ig, which in turn is proportional to V, so we can say that the deflection given in the galvanometer will represent the amount of potential difference directly. So the scale which is graduated to measure the current Ig can now be used to measure the potential difference V. Now this is a voltmeter which we were considering. It is a very high resistance device and its value of resistance is G plus R, which is much greater than the value of resistance of the galvanometer. I hope this is very clear to you. Now here we will discuss some key points of a voltmeter which is very important, and you should know these points very clearly. The first point that we are going to discuss here is, a voltmeter is placed in parallel with the circuit element across which the voltage is to be measured. Because of its high resistances, draw a very small amount of current, and the potential difference across the element remains practically unaffected. That is the thing which we have discussed earlier in the slide, that when a voltmeter is connected in parallel with the circuit, it should draw very small amount of current or negligible amount of current, so that the current in the circuit is not disturbed. So that's why the voltmeter has a very high resistance. So that allows it to draw very less amount of current. Now since a voltmeter is in series combination of a galvanometer and a high resistance, so the resistance is much higher than that of the galvanometer. Okay, So you need to understand the value of capital R, which is the resistance which is connected in series with the galvanometer, has a much higher value of resistance than that of the galvanometer. In an ideal condition, the resistance of a voltmeter should be infinity. Higher the range of the voltmeter to be prepared from a given galvanometer, more should be the value of the resistance which we have connected in series. The value of R is higher, then more voltage will be calculated, the range will be more. The voltmeter of lower range has a lower resistance than the voltmeter at a higher range. Obviously, this is because the value of capital R is changed. In a lower resistance, the value of capital R is low. In a higher resistance, it will be high. The last and the most important point, in ammeter, we have seen that the range of the ammeter can be increased, but it cannot be decreased, but not in case of voltmeter. In case of voltmeter, it can be increased as well as decreased by either increasing or decreasing the value of the resistance R which is connected in series. So I hope that everything is clear here, but still then if you have any doubt, you can post me the doubt. Thank you.